Let's go continue. Hello everyone. In this video, I would like to introduce the three common used motion control function blocks. One is velocity, one is the relative move, and one is absolute move. Those three function blocks are common used motion control function block when the axis in automatic control mode. Let's continue program within this major function block. Firstly, let's drag this move velocity. Okay, multiple instant. And program one execute. Input. So execute MC execute velocity. And then drag this command to here. Once we give a trigger signal to this, axis will run the speed with the setting at here, the velocity speed setting. So our axis will run as a speed control. If we need to set up this velocity speed, so we can create one input interface and we can drag to this interface to that speed velocity setting and we can adjust this speed command. And that is a long rail. Okay. Keep in mind that is a long rail and we can drag to here. So once this execute got a trigger, the axis will run with this speed setting. And keep in mind, it won't stop until you control it stop. For example, MC Halt or MC stop. We will explain this after. And next one, that is the move relative. Click this multi-instant. MC relative. This MC relative will run as a positioning control. It doesn't care the actual current position. Every time it got a trigger, the execute trigger, it will run the certain distance based on your setting and run the certain distance based on this value. Okay, so similar way, firstly, I will set up one trigger signal. And here we can set up set point, long rail, MC relative. Okay, and drag. Firstly, drag this axis, and then drag this execution control signal. This is the relative distance. Drag there. Okay, here. And then let's program this move absolute. Actually, for the positioning control, this is a very common used function block for the positioning control. So let's drag this move absolute, multi-instant. And this is the MC. So once we trigger this function block, it will run based on this positioning. It will care about the current position. So keep in mind this. It will not go continuous to run. It will run the absolute position. So before we control this move absolute, make sure you home the axis correctly. If your encoder lost the position and you accidentally trigger this move absolute, so maybe your axis will run far away or crash somewhere. So keep in mind this. Similar way, we will create the input execute, and here the actual position value declared one input long rail MC absolute position. Okay, let's drag this execute and absolute position here and drag this axis. Here, some people will ask if we need to control this axis, do the multiple different position control, how we can do that. Do I need to drag the different move absolute function block within this FB? Yes, you can, but actually the reason why I set up this execute and this position control running as the interface here, that allows us to only use one function block, this move absolute. And then you can involve the sequence control. So every time you set the new position and trigger this function block, the axis will go to move. And once the axis go to move and got a down signal, that means the axis already arrived at that position. And then you can set a new position and trigger it again. So your axis will move to the next position. For example, if you are controlling one pick place, you can set up the new position and trigger this position. And this will control the pick place move to the different place. Okay, so that means if you can organize the trigger and positioning command and then signal very well, actually one function block here, that's enough. But if it's too complex for you, so you can still use individual function block. Every positioning control, they can represent each individual position. So you can trigger them individually. Till now, we programmed the three important function blocks. One is a velocity, one is an absolute position, one is a relative positioning control. Those three function blocks, once we trigger them, they will execute, especially for the speed velocity control. So once we trigger the axis, the motion will move. During the motion movement, if we want to stop the axis, how we can do that? That turn to two important function blocks. One is MC Halt, one is MC Stop. So Halt will temporarily pause the axis. Okay, drag the multiple instant. Okay, this is the MC Halt. Okay, we can here add a row, and this is the execute. Okay, and drag to here. And the axis, we can drag that axis TO to this axis here. And keep in mind here, so once we trigger this Halt, that control signal is a trigger signal. So the axis will follow the setting at this deceleration and a jerk. It will stop the axis. Once we trigger this function block, it will stop the axis. Okay, next one, that is a stop. Drag this here and multiple instant. Okay, and name it MC. MC stop. Okay, and so for MC stop, I will prefer to use a control MC stop here. So drag this MC stop, drag to this execute here, and the axis let's drag to here. Some people will confuse at this MC Halt and MC stop. What the difference between them? So the key difference is this execution. If we hit F1, try to find the help of this MC underscore stop. So we will see if this signal get a true, so the motion will be stopped and the new motion job are prevented. So that means this stop, if this control MC stop turn on, even if you trigger the move absolute, relative, or velocity, the axis will not move if this signal is on. But for the Halt, this execution is just a trigger signal. Once this MC Halt is triggered, so the axis, when it's moving, so the axis will stop, and the power will still on, but the axis will stop. Comparing with this MC stop, once we give this command on, true signal, so it will hold the axis, will not execute any motion. Take one application as an example. We can imagine if this axis is controlling one lead screw, and this lead screw is for loading the part to the robot. When the robot comes into this loading zone, so that time the robot should send to the PLC one signal. This signal will be on while the robot is in this zone. And this signal will be connected to this MC stop. This signal will be used to hold this motion, to prevent this motion move. And once the robot leave out of this zone, so it will off this signal. So we can execute, we can trigger other motion, let this motion move to the other place. So this on signal coming from the robot and going to this MC stop, that will prevent the leading screw crash with the robot. But this MC Halt, basically it will be used as a common logic to stop the axis while this axis is moving. Okay, this is the key difference between the halt and the stop. Okay, so till here, if we shrink all this axis, we can see we drag all the key MC function blocks. And other than this, we can feedback our velocity or the actual position from this TO. So to feedback the TO actual status, we can drag here. Let's use the move actual values. Okay, firstly, let's feedback the actual speed, that is the motor speed. To feedback speed, so we can drag this axis TO here and type the dot and find out the actual speed. Okay, and here let's open another branch, still use the move, and let's find out, the actual velocity. The velocity is our axis velocity. Okay, and then the actual position. Actual position here. And then let's go to the output of this function block. Let's declare 3 variables here. Output actual speed, actual velocity, and actual position. So we can drag to this actual speed, actual velocity, and the actual position. Okay, this is our actual value. And other than this, one key important signal, that is standard still. We do need a signal. That signal represents the movement of this axis. Basically tell us this axis is a stop, is at a stationary status. That signal named standard still. So we can use the standard still from this TO. So we can use this way. And to find out the axis standard still signal, we need to find out one menu. You need to find out i7 1500 PLC axis functions. Find out this and search the standard still. We can find out this 3.12.3, this chapter, and click this. And here it explained this standard still signal, it comes from the status word x7, this bit. It can represent if this axis is in a movement status or is at a standard still status. This error word x12 is also important. That means the positioning error has occurred. So we need to grab those 2 bits. Okay, this standard still signal comes from the status word, and that is x7. So keep in mind, we need to use this %, this symbol. And this is standard still signal. And then the output, we can output as a bool signal. Okay, let's insert one row, output MC underscore at standard still. This is a bool signal. And drag to here. And also in some cases, other than this standard still, we can also compare the actual speed. We can also involve the comparison with the velocity. For example, we can drag the compare. That idea is we can compare the motor speed and the axis velocity. For example, we can drag this motor speed, this actual speed value, and the minimum we can type in the -1, and the maximum, that's the 1.0. We can manually set up one window, and secondly compare the velocity. So using this way, we can guarantee the speed is almost 0. If this standard still bit give us a 1, basically that means this axis is a stop, is at a standard still, it's not movement. Okay, this is standard still. And the last but not the least, that is the error signal. We want to grab all the error signal into one bit. So when this bool turn on, that represents this axis has an error. So this network, we can name it error summary. So from this output here, we can create another bool signal output. Error. This is output. Okay. And this output, we can drag to this output MC error. Okay, the arrow can come from different places. One is this, the arrow word X12. That means the positioning arrow. Okay, this X12, that especially means the positioning control. And other than this, we can compare the arrow word. This arrow word should be 0. So we can use this arrow word. This word should be, so compare if this arrow word equal to 0. And the detailed definition for different bits within this arrow word, we can find out the description from this access function, this menu. And it's showing here for different bits. If the system do not have any fault, so this arrow word, it should be the 0. And other than this, we can grab the arrow signal from each function block here. Okay, so for example, we can drag here. So the first one, that is the reside. So we can use this internal function block. So firstly, that is this MC reset instant. Copy to here, instant, click dot, and select this arrow. Okay. And next one will be the home, power, jog, and so on. We program them here. Their logic should be the parallel. That means one of them, the arrow turn on. So we need to output this arrow signal. Okay, after program this, let's close all the network, shrink them, and we can have a over picture. So all those function block and the key feedback are the key functionalities for controlling the positioning control. And the key function block that actually is this MC absolute, this one. For the different trigger and the positioning set point, so we will set by using these two inputs. And every time this task done, so we need to read the task done, and also probably you need to read the busy signal. So we can create another output here. So from this output, the reason why we need this two signal, especially this done signal, because we need to use this done signal to allow next movement, next move trigger to turn on if we have a multiple movement task need to do. So every time we trigger this, we wait for this done signal. After we get this done signal, so the sequence could move to the next step, set a new positioning value to give a new trigger. Okay, so we drag this done signal and the busy signal. Okay, basically this is a typical, this is a major function block. And after this, we need to go back to the main program or other function block. We need to call that function block. Okay, so for example, at here, we can drag this FB100 to here. And here, we need to create one instant DB. And this is the instant DB of this function block. And here we can name it conveyor. Okay. Okay. So as we can see, a pop-up error here because we haven't dragged this actual TO, this position access to this function block. So we need to drag this DB1000, this TO, to this access TO here. And then we need to declare the variables. That variables could come from the M address or other DB to give the execution or set point to this function block or receive the signal from this access. And also you can imagine if you have two conveyors, and then for the next conveyor, you can create a new TO here and drag a new FB100, and the next DB could be 102. And at the next conveyor, you can drag the next TO, that could be DB 1001. So if your system has a multiple single access, you just need to drag this FB100 and use a different instant DB. So it will be very quick to set up the multiple positioning access control. Alright, to connect those interfaces, I will create a new date block. And that new date block has those interfaces variables. Let's create one date type, and the variables within that date type can match with those interface. And based on this date type, we can create one date DB. Okay, so let's firstly create one date type. Double click, date type. And we can rename this date type properties and rename that date type user date type. So UDT underscore application access underscore TO. And then let's create the names. So this date type can match with those interface. So the first one, for example, that is exe underscore mc underscore reset. Follow this way, we create all other tags. Okay, keep in mind the side point for the velocity, move relative distance, and move absolute distance, they are L long rail. And the feedback for the actual speed, actual velocity, and actual position, they are long rail here. Okay, we create this date type here. Let's close it. Come here, add a new block. And click this date DB. And here, this date block, we can name it date block for the conveyors. And this manual number, we can name it, for example, name it 210. Okay, this is for application. Okay, click OK. So here, let's set up the conveyor 1. Conveyor 1. So date type, we will use the date type we just created. So here we can type in the UDT. So this is UDT underscore application access. So it will pop up. Let's double click. So once we select this way, once we expand there, all those variables will be declared within this DB10. So for the second conveyor, in case in your application, you can create the second conveyor. And once you select this, so it can quickly set up all the tags for each conveyor. For this conveyor 1, we can flow this, and then we can connect all those tags to the interface at this function block. So we can drag this MC reset, drag to this input here. The standstill, that is the output. It shows the status of the access. So arrow, this is so this is the done signal, and this is the busy signal. Here I lost one error signal. Let me show how can we add one new variable into the UDT and update this DB block. Okay, come here, let's add one arrow, add one line, insert one line here. And then come back to the date block and right click, click update. So we do not need to recreate. So it can update automatically. So all the existing one will not be deleted. So it can automatically insert this arrow. Actually, in your logic, your control logic will control all those variables. And from your sequence control, probably you can use the actual speed or the done signal and the busy signal from this DB10. Alright, till now, we finished this essential major positioning control function block. And in this function block, we have all essential sub MC instructions. For example, home, reset, power on, positioning control, jog, and stop and halt. So we can use this function block as our template. This is my personal style for your reference. And in next video, we will show how can we download this function block to the PLC sim and use the simulation software PLC sim and to run this access. And also I will show how can we use the control panel to forward and reverse to do the initial test on this virtual access. In actual cases, this control panel is very useful. In next video, I will show this online test. See you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.